Welcome to the final unit presentation for EDUC 519, Crowe Williams. We're going to go ahead and present our instructional unit on probability for high school students. Due to the varying technologies used in this presentation, you will see some watermarks. It's a function of the fact we're using the free versions. We've tried to be ambitious with this instructional unit. We want students to be able to explore both the concepts and applications of theoretical and experimental probability within the context of a high school Algebra 1 course. We've chosen a variety of activities and assessments to engage diverse learning styles, with a culminating project where students invent their own games with random elements. A number of different technologies are used within the classroom as an extensions outside the classroom to achieve these goals. Here you can see the relevant Pennsylvania state standards for our unit. Some other standards, from the upcoming Common Core Math Initiative and the state of Texas, are also referenced within lesson. However, these standards do not capture all the pertinent details that our probability unit covers. During the design of the unit, we created this concept map to illustrate the ideas needed to master our unit's objectives. And this chart illustrates the sequence of lessons used to achieve our instructional goals. You can see that there are a variety of topics related to probabilistic content within the unit to appeal to as many students as possible. We're going to examine one of the technologies used within the unit from the National Library of Virtual Manipulatives. This website contains several random number generators that can be used in probability simulations. Within lesson number 5, students are asked to simulate the 2012 World Series, and we're going to demonstrate how this virtual manipulative can be used to conduct that simulation. This is the front screen for the coin tossing virtual manipulative. By default, the simulation runs for 100 coin tosses, and the probability of a head is 50%. In order to use this tool, the students will have to reduce the number of tosses to 7. This corresponds to the maximum number of games possible in a World Series, and determine the meanings of heads and tails in this simulation. One decision would be that a tails would equal a Tigers win, and a head would equal a Giants win. The base activity in lesson number 5 states that both teams are equally likely to win, so we're ready to go. In order to perform a simulation, we just hit the start button. And the real challenge here for the students is coming in interpreting the results. World Series is played to first team to hit 4 games. So if we take a look at this, we see H, or the Giants, win, and they win in 1, 2, 3, 4, 5 games. We ignore the 6th and 7th coin flip. So we'd record this as a Giant wins in 5. And this is a key skill that we want our students to have in both collecting good research data and interpreting it. What the virtual manipulative really does is take the pain out of actually continuing the simulations. For example, we can run another simulation just by hitting start again. And again, we have to keep our simulation goals in mind. So, for this one under our base assumptions, this will be another Giants win, because there are 4 H's by the 5th flip, so Giants win in 5 games. Run it again. Just like the actual 2012 World Series, we're not seeing any Tigers wins here. This one would be 4 H's, 4 Giants wins, and this time by game 6. So this is an example. This is done again within lesson 5 of our unit, of going ahead and using a tool to do probabilistic simulations.
There are different types of assessments for the unit, probability and analysis. We have 1, 2, 3 formative assessments, verbal response to teacher questions, individual student solutions to written questions, and you can see the lessons where those apply, and then group solutions to written questions. Then we have summative assessments where you evaluate the student's understanding for the entire unit. And we have group presentations for lesson 5, a test, written response to open-ended questions for the lessons that you see in the chart, and then student reflection in math journals where you research for understanding. Here we have the screen for the physics classroom, circuit connections. We have the resistors in series. And for the equivalent resistor, you add them up. And then if you want to know what that number is, you insert those in the boxes. And you click to see what your result is. For this one, the answer is 100. Let's look at the equation for voltage. You can also add up voltage to get what the total voltage is. There's the loop for the series circuit. A lot of reading you can do about voltage. And there's our famous equation, V equals IR. And there's the loop, similar to what I had with the slide for lesson 3 with the battery and the light bulb. There you have resistors, means the same thing for V equals IR. Then after you've done all that reading and studying, you can answer some questions. Click on the answer box. And voila, there are the answers. So we return to the tutorial and we look at more questions. Lots of questions with all the answers. This is formative assessment where you get feedback immediately to check for understanding. There again is another box with the answer. We scroll down, look at another loop, and we see at the bottom of the page a different way to go back to the physics classroom. We were learning about current, so we click on current there, electricity, go to lesson 4, series